We use it every single day. We're sending emails, watching videos, just browsing around. And we really don't give it a second thought. But what is actually going on behind the screen? Well, let's pull back the curtain and demystify that incredible invisible journey your data takes every time you go online. It really does all start with just a single click. You type a website into your browser, you hit enter, and boom! In that split second, you've kicked off a process that literally spans the entire globe. So let's follow that tiny request on its amazing journey, from your screen, out into the world, and all the way back again. Okay, so our journey starts right here, with your simple request to visit a website. It feels instant, right? But that request is about to become one traveler in a global network of truly mind-boggling size. Get this, 5.6 billion. That's how many other internet users are out there. Your one little request is joining a colossal conversation happening between more than 30 billion connected devices. Your computer is basically just one voice in a massive worldwide choir. Now, before our request can even think about leaving your computer, it needs an address. But the internet doesn't work with addresses like 123 Main Street. Nope, it needs something way more specific, something computers can actually understand. For us humans, it's easy. We navigate the web using simple, memorable domain names, like Nike.com. It just makes sense to us. But for the computers and routers that make up the internet, a name like this is basically a foreign language. They don't speak in words, they speak in numbers. This is what computers get, an IP address. It's a unique numerical label for every single device connected to the network. So the big question is, how does your computer translate the name you typed into the number it actually needs to send your request? Well, it uses something called the Domain Name System, or DNS for short. The easiest way to think about it is as the internet's giant global phone book. When you type in Nike.com, your computer pings a DNS server and asks, hey, what's the number for this name? That server looks it up and sends back the correct IP address. And now, with that number in hand, the real journey can finally begin. All right, so we have the destination address. Great. Now, we've got to package your request for its trip. Here's the thing. Sending it all as one big file would be super inefficient and slow. Instead, the internet uses a much, much smarter system. See, way back when, telephone networks used something called circuit switching. It was kind of like booking a private road just for your phone call. A totally dedicated connection that no one else could use until you were done. The modern internet, though, uses packet switching. This is way more efficient. It's like breaking your message up into a bunch of small postcards, and each postcard can take a completely different route to get to the same final destination. This whole process is managed by a set of rules or a protocol called TCP. So, first, TCP takes your request and divides it into these small, numbered chunks called packets. Second, each of those tiny packets gets a header slapped on it with the destination IP address. Third, they're all sent out onto the network. They might even take different paths to get there. And finally, and this is the really clever part, because they're all numbered, they can be perfectly put back together in the right order at the destination, even if they arrive at totally different times. It makes the whole system incredibly tough and resilient. So our tiny data packets are addressed, they're numbered, and they're ready to go. They're about to hit the global superhighway, a truly mind-boggling web of physical cables and hardware that connects the entire planet. The packet's path starts right in your home, at your local router. From there, it zips off to your internet service provider, or ISP. Your ISP then connects to even larger networks at these things called internet exchange points. Think of them as massive, bustling intersections for data. And ultimately, your packet hits the internet backbone. These are the huge Tier 1 networks that own the massive, high-speed fiber optic cables running under oceans and between continents. But there's also a really important security feature at work here, right at your router. It's called Network Address Translation, or NAT. See, all your devices, your phone, your laptop, your TV, they all have their own private IP addresses. But NAT acts like a digital receptionist. It only shows one public IP address, your router's, to the outside world. It then figures out which internal device gets which piece of data. It's a simple but really effective way to hide your personal devices from the wider internet. Okay, our packets made it. They reached the destination server, which then sends back the website's data, also broken into packets. Now comes what's called the last mile, that final edge of the journey back to your device. And this is what really determines the speed you actually feel. The physical tech your ISP uses makes a massive difference here.
Satellite internet is great for reaching remote places, but it's usually the slowest. Cable is a big step up, offering much faster speeds. But the real gold standard today is fiber optic. It literally transmits data as pulses of light, giving you the fastest, most reliable speeds you can get. But speed isn't just about how big of a file you can download. It's also about responsiveness, and that's measured by latency. It's the total round-trip time for a single packet to go from you to a server and all the way back. You might know it as your ping rate. Having a low latency is what makes your connection feel snappy and instant, which is absolutely crucial for things like online gaming or video calls. But the journey isn't always perfect. Sometimes things can go wrong. You might run into something called jitter, which is when packets arrive at weird, inconsistent intervals. That's what causes a video stream to stutter and buffer. Or even worse, you can have packet loss, where some of those data postcards just get lost in the mail completely. Your computer then has to ask for them to be sent all over again, and that, of course, slows everything down. So after all of that, from a DNS lookup to packets being broken up to data flying across undersea cables, the website just magically appears on your screen. And maybe the most remarkable part of this whole thing is that no single person, no company, no government owns this entire system. It works because of a shared global commitment to common rules, which leaves us with a really critical question. How do we as a global community make sure we protect this essential resource to keep it open and working for everyone for years to come?